Machine learning, data science, and artificial intelligence are quite the buzzwords in the tech industry nowadays. Hello, Miso Hacks, and welcome to the Hands on Machine Learning Workshop. Hope you are having a great weekend. Now, wait for 5 more minutes for the people to join. Till then, why don't you tell us where are you joining us from? Hey, hi Aditya, hi Adnan, hi Ashish, hey Advik. Okay, hey Samir from Delhi. I am personally from Meerut, so we are close. Okay, Adnan is from Kolkata, Poonam is from Mumbai, Ashish is from Orissa. Nice. Hanak, hey Hanak, I hope I'm taking your name right. Yug is from Bangalore. Okay. Ethiopia, oh, we have some international guests. Nice. So I guess we should proceed now. So let me introduce myself. I am Kanak, a final year BTech student from Graphic Era University, India, and I am currently working as a data science intern at MPL. And I love hackathons and communities and have participated in over 50 international hackathons and won something in over 20 of them. So yes, I am a veteran hacker. You can ask me anything regarding hackathons, or if you have any troubles in submitting your hacks or submission videos, anything. Okay. So let's quickly set the agenda for today. So to set the context, we will be starting with a quick introduction to machine learning. Then we will be solving the iris flower classification problem in Python. And finally, we will be solving the exact same problem without writing even a single line of code using Azure ML. So Azure ML Studio is a completely free service by Microsoft. You won't even need a credit card to register. In the end, we will be deploying our solution so that you can incorporate that in your projects. So our end goal for this workshop is to enable hackers to add an element of AI ML into their projects, of course, if you wish to. Okay, so let's proceed. So what exactly is machine learning? Would anyone of you like to answer? Let me go back to the chat box. Automated reasoning, okay, and problem solving. Okay, you're there. Machines finding patterns in data to make decisions. Yes, Samir, right. Okay, let me give a formal definition. So, machine learning is a subset of artificial intelligence that focuses on teaching computers how to learn without the need to be programmed for specific tasks with the help of the data. So, why I'm saying without being explicitly programmed is because let's look at two different problems: cat and dog image classification and plant disease classification. Now, both are quite different problems, right? And with a traditional programming approach, you will end up writing a separate code to tackle them both. With machine learning, you just need to change the input and output data, and the exact same algorithm will learn how to perform either task. Isn't that interesting? Now, let's draw further comparison between traditional programming approach and machine learning approach. So in traditional programming, you have your data or the inputs you give to the program, and your task is to create a program or build the logic for it. So you provide both your data and program to the system, and you get the desired output. In machine learning, on the other hand, you have your input data, you also have their corresponding output. So when you provide the computer both of these, it will work out the logic necessary to translate the specific input to the associated output. That's why it's called artificial intelligence, right? The computer is learning how to perform a specific task by observing the data you feed into it, just like human beings learn. So yeah, any doubt up till now? Okay, I think we should proceed. So if that context is set, so I believe if a picture is worth 1,000 words, then a video is worth 1,000,000. With that in mind, allow me to show you some of the most amazing machine learning projects you have ever seen. So you have probably played Subway Surfers with your fingers, but you have ever tried it with your camera? This project does exactly that. Any Harry Potter fans in the house? It appears that wearing a cloak of invisibility is no longer just a fantasy. And at least some of us must have tried the style transfer to create prank videos with our friends, and we all love them. Now, let's look at some of the industrial applications of ML. So, Netflix uses machine learning for series recommendation systems. Voice assistants like Alexa are becoming a part of our daily lives. Face recognition service is a powerful security tool and quite a time saver. We see email spam filtering in action every day. And don't we all wish to own a Tesla one day? At least I do. This is all possible because of machine learning. Now, enough of the theory. Allow me to show you how easy it is to incorporate machine learning into your projects. So let me switch screens. Okay, yeah. Also, any doubt up till now? No, I guess. Yeah, okay. So this is a classic problem of iris flower classification in which we will, there are different, so iris is actually a flower and there are different categories of this flower. So we will try to predict the category of the flower on the basis of different features like sepal length, sepal width, petal length, and petal width. So this is actually a very classic machine learning problem. Let's list out all the steps first that we are going to take. So first we are going to import the libraries. Then we will import our data. Then we will perform some EDA. EDA is exploratory data analysis, by the way. Let's make it a little big. Then we will split our data. So let's name it that. Next, we would go on to modeling. Then we would evaluate our trained model. Finally, we will be saving our model so that you can use that in your projects like a Flask app or something. Okay. So first, let's start by importing the libraries. So we would import pandas. Pandas is a popular library to work around with CSV files and other data frame formats. And we also need, okay, just connect. Okay, yeah, also let me introduce you to this tool. This is Google Colab. So you can use it to uh, create a virtual kind of a cloud environment of Jupyter notebooks. So you don't need to set up Python or anything on your own system. You can just use this service, and it also offers some GPUs for free. Like if you need to train a deep learning model, you can use the free GPU service of this, and it is really, really helpful. And we need pandas and we need plotly for drawing graphs. Next, we will be importing our dataset. So in the pandas library, we have a method read CSV, and let me upload the CSV file. So here we have a CSV. I'll provide you all of this after the workshop if you need to play around with it. So now our data is loaded into the memory. So let's actually check out the top 5 rows of the data. So head method actually returns and prints the top 5 rows of your data set. So we have these 5 columns in our data. One is the class which we are trying to predict that either the flower belong to class 0 or class 1, and these are 4 other features of our data set on which the class is actually depending on. So if your sepal length is, let's say, 6.3, width is 6.9, petal length is 5.6, and petal width is 1.8, so the rule is that mean the flower belongs to class 1. Now we will not be writing a particular logic for it that if the length is greater than this and width is greater than this. No, we are going to train a model for it, and the computer will figure out what are the rules necessary to predict this class correctly. So next part is exploratory data analysis. So good way, mean this is kind of an important step in the machine learning project lifecycle. So if you know your data really well, only then you can train a good model on it. So exploratory data analysis stands for exploring our data and finding manual patterns so that we can optimize our model once we train it. So let's quickly check the length of our data first. So we have 100 data points, and we have a method called describe. So this method returns a series of different things. So we have count, which stands like how many not non-null values we have in each column. Then mean is the average value in that column. STD is standard deviation. It means that how much on an average a value deviates from the mean. Then we have minimum value, maximum value, and these are the quartiles. So quartiles means, so if you sort all the values in this column, what will the 25th percent of the value look like? So if the 25th 5% of the data points, so like this shows that if the sepal length for 25% is 5, that means 25% of our data points have a sepal length of less than 5. Similarly, 50% is actually median. And actually, this is really interesting. So we have only 0 and 1 in our class, and a median of 0.5 suggests that we might have exact number of data points belonging to either of the classes. So let's actually check that as well. So actually we need to just check the length of this. So here it is. Yeah. So yes, we have total 100 points and 50 of those points belong to class 0 and the other are definitely gonna belong to class 1 then. But still let's check it out. So we have a perfectly balanced data set with us. Also, let's also manually check the null value sum. So although this is already giving you the counts as 100, so we know that there are no null values in our columns, but still not all data sets are this good. So it's good to check it out this way. Okay. Also, let's draw some graphs and see the correlation between these columns. So we can draw a scatter plot and we can give our data. Then let's draw between sepal length and sepal width. So sepal length could come here. So this method is just suggesting that we are going to use the data from this data frame. Then the x-axis values are going to come first, then the y-axis values, and we also need to see the class it belongs to because then otherwise it makes no sense. So we are going to give it a distinct color based on class. This is actually not really visible. Also, let's give it a specific symbol. Did I commit some mistake? Okay, I should write it in small. Yeah. So now these are actually an interactive plot, so you can play around with it. Also, we are currently making a ML model, but if you had to do it the traditional way, so if you have this analysis, you can pick out this area of the graph. So you can say then that if your sepal width is greater than 2.9 and your sepal length is less than or equal to 5.8, then you can simply classify it as 0 and only one data point will be left in that case, and I don't think we can do anything for this because so we have to either choose this or this. So in that case, I guess we will get less number of misclassification. So using if you choose this method, so you will still be able to predict 99% of the classes accurately. But we are going to train a machine learning model for it, so we don't have to do any of this. Let's also check out this correlation between petal length and petal width. Okay, these are completely different classes, so we can easily figure out rules for it now. If we have to, but we are not going to do that actually. But if we have to, we can simply say that if the petal length is, let's say, greater than or equal to 1 and our petal width is less than or equal to zero point 0.6, we can simply classify it as class 0, otherwise class 1, and it would predict 100% of the points correctly. But not all problems are this simple, okay? So in those cases, you have to kind of use machine learning. So yeah, now we are going to do the splitting of data. So for that, so there's a very common step in machine learning. So you separate out your labels and you separate out your features, and then you feed the features into your model and you like ask your model to find out the logic to map this input to a particular output. So we are going to take all the columns which we are going to use to predict the features, which are these. So like either you can take all of these separately or you can just drop the class column. And don't worry if this sounds a bit overwhelming to you. We are also going to see the no code solution for it. That is very, very, very simple. So you don't have to write any code. So just stick around for that. So we took the so X is actually referred to as commonly referred to as independent variables or the features on which the label is going to depend, and Y is your label. Now we are going to split our data into test and train splits. So why? Let me first import the library. Autocomplete is not working. Okay, so what happens is like assume that you are a teacher and you want to teach something to your students. So you will you give the exact same questions in the exam that you are going to use them to teach them? No, right? Like in that way the children could actually just memorize all the date all the problems that you tell them, and they can still score good marks. But we don't want our model to memorize, we want it to generalize. So what we are going to do is we are going to take 80% of this data to train our model, and on the rest 20% we are going to test our model. So let's quickly do that. So all you have to do is provide your X and Y labels, and it returns four things. Let's actually copy paste it from here. Save us some time. So we are going to give the test size, which is point to like we need 20% of the data for testing, and the rest 80% will go into training. And then we are going to give it stratify is equals to y. So what will stratify do is let's say we have 50 each column in our uh, original data for each class. Now either we can do a random split in which we might get 50% of those, or like this could happen, right? We can get all samples belonging to one class only if we do a random split. To make sure that the columns are balanced in our just yes. So to make sure the ratio of the classes is balanced in the testing data as well, training and test data as well, so we use stratify. Okay. Now in the modeling, we are going to use a very common machine learning algorithm called random forest. So let's actually go to the slides and see that as well. And let me share that back. Yes. So you see this tree-like structure, right? So this is a very good representation of a random forest performing the task of fruits classification. The features in this data set could be of the type like the shape of the fruit, the season in which it is cultivated, or the vitamins found in it, etc. So random forest creates multiple decision trees, and based on these attributes, so when a new data point occurs, each decision tree will produce a prediction results. So for example, these two decision trees in this case said that the fruit is apple, whereas this last decision tree said that the fruit is banana. Then based on the majority of the results, the random forest classifier predicts the final decision. So in this, so two trees are predicting it to be apple versus one, so it will predict it as apple. So now let's quickly move back to our code and train our random forest for our task. So we are going to import for the random forest classifier first. Now we are going to create an instance of it. So we can say like model is equals to random forest classifier. Then for training this model, we can simply call the fit method of it. So it takes two parameters like the training, like the features and the associated labels. And that's it, our model is trained. See, I told you it was easy, right? Now we are going to check that trained model. Now we are going to evaluate it on our testing data. So we took 20% of the data for testing, right? So now we are going to use it. So firstly, we will store the results in a new variable. So now we are asking our model to predict the results on these data points. And we will store it in a new variable called while Now we are going to import dot let's see what options do we have. It is found in metrics, I guess. Oh, sorry. So now we are going to print its classification report. So we just need to pass the true labels and the predicted labels. So we can see we got an accuracy of 1.0 or 100%. So this means that our model was able to predict all of the samples correctly. Now this training is done, but let's say you want to use it for a new data point in future. So for that we need to save our model so that we can simply call it later. So for that we are going to use pickle library. Now we are going to save that model in a file called model.pickle, and we are using write. So let me explain this syntax. So we are going saying that open a file model.pickle in write method, and that to binary write. Now we are going to say ask pickle to dump our model or to save our trained model into that file. Yes, and the model is saved. You can see it from here. You can also download it on your local system so that you can use it later. And for using it, you just need to use the same method actually. So instead of opening it in writing mode, now you will open it in reading mode. And instead of dumping, now you need to load it. So you will call the load method of it. And you can store it in a variable, let's say rf. So now you can use RF to predict the new data points. So you can say like, let's pick some data points from here only. Okay. So it is saying, so if you take the zeroth index, like it expects you to give it a batch of data, multiple data points which it can predict. So if you take the first prediction from it, it is 1.0, which is exactly what this data point belong to, class 1. Okay, so Python part is done. Now we are going to switch to Microsoft uh, Azure ML Studio. And before that, let me see if any of you have any questions. Ask them in the chat, guys. If you have any questions in this method or Advik is saying Python is love. Yes, Advik, Python. I also love Python really. Okay. So let me ping this URL to you as well. So this is what we are going to use to create the no code solution. You can sign up on this website. It's completely free, like I said before. Also, if you are using Brave now, like, so disable all the shields for this website or this website won't work. So we are going to create a blank experiment, and this was actually a data set from this, from the sample data sets only, so we can import that. Now let's uh, write down the basic points we used. Like, let's remember the points we all used in the Python. We imported the libraries which we do not need to do here. Then we imported the data set like we did just right here. Next, we did some exploratory data analysis. So let's analyze this data as well. So for doing that, we can just do it right from here. And let's say we need to compare it, like we draw a comparison between sepal length and sepal width, right? So we can do it from here. Okay. Similarly, we can do like petal length and petal width right from here. So this is the exact plot we got, if you remember. So next in our Python, we did splitting of data sets. So let's split the data sets here as well. So we have partition and no, we need to split. Sorry. Okay. So yes, we need to split rows and we need 80% of the data for the in the training. So this is what it is asking, like fractions of rows in the first output data set. Then we can give it a yeah. So remember we did a stratified split. We maintained the ratio of the classes in our Python. So this we can do it right from here. So it is asking on what basis you want to stratify it. So we are saying on the basis of class like we did there. Okay. Next, we jumped on to modeling. So for modeling, we use random forest. So let's find random forest. So we have here two class decision forest. So which is actually a random forest only. Actually not random forest. This is decision tree. Let's import random forest. Okay, it has only this option, I guess. So we are going to use this. Yeah, this is forest only. Yeah, we can use this. Now we need to train our model. So we can just simply do train model. So we can provide it with the algorithm and the data, and let's just run it. And okay, okay, wait. So we have to run this first. Okay, I guess there is some problem. Let's run it now. Okay, it ran successfully. Now let's train our model. So you need to provide it with the algorithm you are going to use and the data it needs to consume. And then you are going to tell it the label variable. So for this, we need to predict class. So class is our label, like we did in the Python. We have to just follow the same procedure. And let's run this now. So our model training is now complete. Now let's evaluate the results. So for evaluating, we first need to score it. So we are first going to provide our model and the remaining 20% of the data we kept for testing it. And finally, we will evaluate our model. So let's move around a bit. Let's run. Yes, these were all the steps, and now we could like evaluate the results ourselves. So it has also given a accuracy of 1.0 or 100%, and it was also able to predict all the samples correctly, like our model did in Python. The next thing we did there was to save the model so that we can use it later. So for that, we can do something even better. We can set up a web service for it. So we are going to set up a predictive web service. So now you actually need to do some additional steps. So right now what it is doing is it is taking the complete data as the input and then using our trained model to run predictions. But in our complete data, if you remember, we have class variable as well. Now, don't you think this is kind of wrong? Because the class is what we need to predict, and if you are going to ask the end user to input the class as well, then what's the use of the model? So we are actually going to remove this column from our data set. So we can do that using selecting select columns in data set. So we will remove this link, we will join it with this, and we will connect this here. Now in selection, we would only select these four columns and remove class from it. Okay, we can run it. And now we can simply deploy it. So you can test out your model here, but we are going to test it out using Python, because I am thinking like some of you are going to create Flask or Django backend apps. So using this method, you can simply add an element of AI or ML to it if you wish to. Okay, I have to switch tabs again. Oh, wait. Wait, why I'm not able to share this one? Yes. So you see the screen. So you'll have to go to consume, and it will already give you a boilerplate code for it. Like not just boilerplate, this is actually the complete code for it. So you can use this in C Sharp, Python 3 plus or R by default, and you can also find a way to use it in uh, using your JavaScript as well. So we are going to copy this code and paste it in Visual Studio Code. Let me share my entire screen. This way I don't have to share it again and again. So we are going to create a new text file, and this is the complete code that they gave us. So let me explain this code really fast. So we are importing the request library and the JSON library, and then we are giving our input. So if you want to customize it, you can ask from for this input from your user and then put it into this code. And for API key, they already provided us with an API key here. And this is actually the only change you had to make to this code for it to run. Let's save it as iris.py to desktop. So now we can run it. Okay, so it gave us this long kind of result. Let's modify it a bit. So we are actually, I'm not sure if this is visible to you. Let me see if we can. Uh, let me paste this up so that you can see. This is the long output that it gave us. But we are mostly concerned with code labels. So this is what it predicted it to be of class 0. So let's take it out from this. So for that we can do, so it will convert this into a dictionary. Then we can print it, like we can print result. Then we can see the first key we have here is results. So we need results. Inside of that, we need output 1. Now inside of that, I guess this is a list, so we will have to index it. Then inside of this, we need the code labels. I think it should work this way. If not, we'll see. Yes, so we were able to predict it 0. And let's change these to check if it is working right or not. So let's pick out this example this time, or this one. So we can change it 6.7, 3.1, 5.6, and 2.4. It should, for a correct prediction, it should predict it to be 1. Yes, that is what it predicted. So this way you can set it up on your system. It is, you don't need to be you don't need to have a lot of machine learning knowledge to use this kind of tools. You can just use it to train your models. You just need to know the right steps you need to train it. Like, you have to load your data, you have to split it for evaluation purposes only, or you can use your entire data if you're confident enough. And you can use your, then you need to like import your algorithm and just train your model and then evaluate it and just set up a web service. That's it. Okay, so let's finish our PPT now. So let me go full screen. So now let's look at some of the career prospects of AI/ML. So AI and ML jobs have jumped by almost 75% over the past 4 years and are poised to keep growing. Pursuing a machine learning job is a solid choice for a high paying career that will be in demand for decades. Industries that are already using AI and ML heavily include healthcare, education, marketing, retail and e-commerce, and financial services. Also, AI and ML is interdisciplinary in nature. So it doesn't matter if you belong to a CS background or from a mechanical background or from a biotech background. You can always find some use cases of AI and ML in your own field. Okay. Now the next question is how to learn. So these are some of the resources that I personally use to learn machine learning. You can take a quick screenshot of it if you like to uh, visit some of these resources. Like I would suggest you to take a screenshot of it. Okay. Okay. So thanks for making it so far. So any questions? I'll just jump into the chat box now. Okay, sir, after learning how to clean data and train model, can we practice on Kaggle? Yes, absolutely. Uh, Kaggle is actually another great resource that provides amazing data sets online. I always use Kaggle to find amazing data sets. After like learning how to clean data, like that is cleaning data is essentially the most important step in any machine learning model. Almost 70-80% of your time goes into cleaning data. After you learn how to, after you no, you don't even need to master that. Like you can jump onto Kaggle competitions now, and yes, it is the best resource you can find to practice online. And Ashish is asking how to know what goes inside model function. So actually, this is something that you gain from practice only. So firstly, you just need to experiment it in the start, and you actually need to get the mathematical functions. You need to know how it actually works. Like if we talk about random forest only, there are functional like we have entropy and information gain, and a lot of stuff is there to learn in just this simple random forest. It's not like you need to know what features to select first, what would come on the top, and then you have to make the prediction. So once you learn that, this is something that that will come organically to use. So you will learn how to use, how to optimize the hyperparameters that way, or how to make a model yourself. Yeah, that's what I was talking about. Like you need to learn the mathematical functions behind it, and then I would actually, this is what is also recommended. You should actually try to make a model yourself without using these inbuilt functionalities. That will give you a very much deeper understanding of the model, and then you can, I mean, you are actually going to use it 90% of the times, to be honest, the inbuilt functions. But yeah, it is always good to know. Sanyam is asking, sir, after learning how to apply ML algo, clean our data and train our model, can we start practicing on cable? Yeah, we have already answered that. So yeah, we should all, I mean, yeah, just go ahead, start practicing. Okay. Any more questions regarding hackathon as well? Like if you don't have a question in ML, it's also fine. You can ask other questions as well. Okay, Aditya is asking, how did you get started with hackathons? So, this is actually a really interesting story. So, in June last year, I applied to MLH fellowship, and I got rejected. And the reason I the for my rejection was that I didn't have enough personal projects to showcase my ability, and they also advised me to participate in hackathons because it is one of the most amazing ways you can create more projects while having fun, of course. So I said, okay, let's try that out. And the first hackathon, I made a simple cat and dog image classifier. So that is like a hello world in like convolutional neural network. So I didn't win obviously, but I had a lot of fun. Then in the next hackathon, I found amazing teammates Aditya and Harshal. Aditya is actually the lead organizer of this hackathon. So we made an app called Money Trek in that hackathon. It was a simple app on which you can like scan your bills, and it will figure out the amount and the things you spend it on, and it would split the bill amongst all the friends. So we won vacation hack. There was a prize category, vacation hack. We won that hackathon, and then we just continued to participate. And there was a weekend, like not a weekend, there was a series of weekends. Like we won 7 uh, weekends in a row. So, and that streak ended with me participate not choosing to participate because I wanted to go to watch Spider-Man. Yeah, so we have lots and lots of memories with hackathons. And you can, this is what hackathons are all about. Just have fun, make projects, make friends, and participate in a lot of hackathons. Workshops are always fun. Yeah. Any more questions? Okay. Chaitanya is asking, which resources would you recommend to get started with building your own model? So yeah, let me actually share the link of that course. So there is an I will share that after this stream. So there is an amazing course by Andrew Ng, which is recently upgraded as well. It is machine learning by Stanford University on Coursera, and it covers all the mathematical concepts and tells you how to actually implement all these models from scratch in Python. So Python is a prerequisite for that course, and you can get started. It is actually not free if you want a certificate, but you don't really need a certificate. You just need skills. So you can learn that course without paying any fee, just by auditing that course. Or if you need a certificate, then you can also apply for financial aid on Coursera. That way you can get it for free. Okay, I guess we can wrap it up now. Rock. Nice. Okay, thank you for joining, guys. Hope you learned something new today. And I will be there in the Discord channel. So if you need any help regarding Python, ML, AI, or any of that stuff, you can just ask me there. Okay, over to you, Aditya.